Graph some lines on our own. We've done a lot of talking about slopes and y-intercepts, and those are very helpful to us in being able to graph our lines. Um, I'm going to concentrate mostly on finding the slope, finding the y-intercept for our equations so that we can use that to help us make a graph. So on this blue equation, the slope is 3 and the y-intercept is -1. And how I know that is just basically by their positions in the equation. I know that the number in front of x is always the slope, and the number that's either being added or subtracted to that x term is my y-intercept. So that tells me then I can go to my graph and I can put a dot at -1. It's got to cross the y-axis there because that's where the y-intercept is. So I have that point at -1. Now the slope is going to help me make more points on this line. From that point, let's make it the same color. From that point, -1, not from 0, 0, but from -1, I'm going to use my slope to count. My rise is 3, so 1, 2, 3. And my run is 1, because there's no number on the bottom of that fraction. I have to expect that it's a 1. So my other point is going to land there. I can continue that slope as much as I want, but unfortunately I can't go too high on here. It fills in the whole paper. I don't know if you all noticed what I did there. Now going up this way, I kept using up 3, right 1, up 3, right 1. But I could also do what you might call the inverse of that. The inverse 3/1 still equals 3, but if I went down 3 and left 1, overall, that's still equal to a +3. So it's what I did to make this fourth point. Instead of going up 3 and right 1, I just did the inverse. I went down 3 and left 1, which still ends up being the same line, having another point lying on the same line. Now to draw this nice steep line and make sure that it's straight is of course a challenge on this tablet. Okay, so that would be the graph for the equation y equals 3x minus 1. Okay, the equation in gray, the number in front of x is a -2. So that's my slope. That's what's going to tell me how to get from one point to the next. If you want to put a 1 underneath there, that's fine. There is no number being added or subtracted to or from that term, so because there's no number there, that tells me my y-intercept is 0. 0 on the y-axis is the point where the two axes cross. So that would be this spot right here. My slope is -2, so that means I want to go down 2, to the right 1. Now that I'm making my graph, I'm not drawing in the triangle that I normally did when I was calculating slope. I want it to be kind of clean for making this graph. So from my last point, I can continue that slope down 2, right 1. Or if I run out of space, I can go back to my y-intercept and do the slope, but do it in reverse. Instead of having the -2 on top, I could have the 2 on the top be positive, but the -1 be on the bottom. So now my rise would be up 2, and my run would be to the left 1. So up 2, left 1, put a dot there. And you can connect those points. My requirement for you, if you're turning in something for me where you have to draw your own graph, is that you do at least 3 points. That gives us the best indication. Sometimes we can draw 2 points. They're going to lie on the same line no matter where you put those 2 points. But maybe we goofed. So then if you do the third one, you might notice, hey, all 3 of those points don't lie on the same line. I must have made a mistake somewhere. Okay, and now the purple graph. M equals 1/2. That's my slope. B equals a +1. That's the number over here that doesn't have an x on it. That's my y-intercept. So I can then come to the graph. I know I'm going to start at +1. My y-intercept is a +1, so I'm going to put a dot there. My slope is 1/2, so I'm going to rise 1, run 2. And this really runs into my notes over here, but I went up 1 more, right 2. But if I run in out of room like I did there, instead of going up 1 and right 2, I could do excuse me, I could do the exact opposite, and I could go down 1 and left 2. And then let me connect those points so that you can see that, yes, they do lie on the same line. When Mrs. Fisher's drawing on this tablet, it may not always be straight. Okay, and we'll do some things on the graphing calculator too, guaranteed to be straight on there for graphing lines. Okay, what happens if the equation that you get is not necessarily in the form y equals mx plus b? So we're graphing lines from an equation. I don't want you to forget what this is. But this time our equation is, let's say, 3y plus x equals 9. Okay? Well, if we're not in the form y equals mx plus b, we don't know for sure what our slope is and what our y-intercept is. You might be able to say, well, Mrs. Fisher, I can do it right from here. I don't need to adjust this to get it in the form, and I'll know. If that's you and you find yourself not making any mistakes in identifying the slope and the y-intercept, then feel free. You might remember from a previous video that if I don't do it on paper and pencil, I make mistakes. The video where I had to change it, the slope from being 6/17 to 6/12, that's the video I'm referring to. I did that math in my head and you see where it got me. So I don't want to have to do that in my head because I make mistakes. In slope-intercept form, y is alone. So I want to work on this equation and manipulate it so that I can get y alone. Well, the first thing I have to undo, remember, is adding and subtracting. Got to undo the order of operations, but in reverse. So 3y is equal to a negative x plus 9. I like to put my x first because that's where it's at in the slope-intercept form. The x is in the front. Then y is being multiplied by 3, so I still have to undo that multiplication by 3. I'm going to divide by 3. And I get y equals negative 1/3 x. I didn't have a 1 up there originally, but you have to understand that there can always be a 1 in front of the x. And 9 divided by 3 leaves me with a 3. So now I have my slope being a negative 1/3, which, remember, in case we need it, could also be 1 over negative 3. And my y-intercept is at 3. So when I go to make my graph, oh, nice and straight here, nice and straight. You, when you're doing yours, can use a straight edge, a ruler of some sort, maybe the side of your planner. Now, obviously, you won't have to draw coordinate planes on Moodle, but you might have to match a graph to an equation, like a matching problem. But there will be some assignments where you'll have to turn things into me and you'll have drawn your own graphs. So y-intercept is 3. I'm going to come up here to positive 3 and put a dot. Got to have that starting point. Starting point is not always at 0, 0. The only time it would be at 0, 0 is if your y-intercept was 0. And back to my slope. It's negative 1/3, so I can go down 1 to the right 3. 1, 2, 3. And I should be able to fit another one on my screen. Down 1, right 3. And if I didn't have enough space, I could have gone up 1 and left 3. So now that I have 3 or more points on my line, I'm going to do my best. Whoops, that was strange. Do my best to connect these points. Again, use a straight edge, side of your planner, ruler. I have plenty of rulers. So that's the line that would represent the equation 3y plus x equals 9.